Hello, welcome everyone. It's another Sunday, and thank you for joining me. We're going to be coding some more databases today, which is, what we've been doing for a while. I think we have the opportunity today, given all of the work that we did with merging and promoting files and so forth, that we can start to think about the public API, and that's pretty exciting from my perspective. We started with the nursery, which is like the minimal amount needed to accept rights, but now we can think about doing reads across the entire database, which is pretty cool. And then if that goes well, we can start to think about writing tests. Now, there are parts of this code that I think we should probably write tests for that are independent of the public API. But the public API is kind of a great place to think about tests, because that's the space that your users, our users of this code, are going to interact with. Now, there are other aspects of the code that definitely need to be tested, but that's for our sake. Really, what the user cares about is, can I write data to this database and read it back? If I delete a key, does it actually get deleted? And so forth. Can I scan keys? And maybe we won't do that right away, but because we haven't built the infrastructure for that. But even just like treating this as a key value store that just happens to be ordered, is a great place to start. There's also some great techniques that we can use for testing this. We can build up scenarios of tests that maybe are randomly generated. So we could use Quick Check, and maybe generate some examples that will exercise interesting parts of the API and the internals. So. And then the other kind of test I definitely want to consider is, hi Chris, welcome to the stream. The other kind of test I want to consider is the benchmark test. Now, that's not just to give us numbers. It's also so that we can push the limits. Now, if we're just going to do some example-based tests, we're not going to push the interesting parts. Like, we'll exercise the nursery in most cases. And that's not that interesting. What gets interesting is when the nursery fills up and it promotes a file to the first level, and then that first level fills up, and it merges and promotes a file to the next level, and so forth. That's where the stuff gets really interesting. So more of a stress test than a benchmark. I want to get to that. So first, let's get going here. I kind of want to review what we did last time and see if there's anything jumping out to me that we need to address. Remember, we spent a lot of time in this file for the level last time, and we talked about computing how much merge work to do, and then passing that to the merger that's already been created. And if it succeeds, then we can either say pass along a merge to the next level, a merge command, or possibly in the case where we merged enough keys that the size of this the output file is big enough, then we can promote the file to the next level. And these other two cases are, well, we merged and we basically got rid of all the entries, and so we can just delete those files, and we can make the C file be the new A file. And I think maybe it's worth saying like some things about the design of the files, which we could potentially put in the README. Like, what do they mean? And some of this is that I was already aware of what the files are, but it's it's nice to document that as well. Okay, so we do have some to-dos in here. um, I think in some ways we do track how much was actually done previously, because we're going from um, the estimate of the work that's done here, and passing that along in this merge command. So I think that we've got that for the most part. But there was an aspect of oh right, this is about keeping in the either in the merger or in this level how much work was done. So maybe we could add that to the merger. And this is the thing where maybe it's a like steps taken. That's something to think about. Okay, so let me say put this in the merger question mark. Okay. We have some questions here about, these are mostly about translating from the original code. The level here should never be greater than the max level that was configured when we opened. But there were some computations in the original Erlang code that kind of considered that. And then there was also the idea that we could do was called the predictable strategy rather than the excuse me, the fast merge strategy. So let's open recent this. And are we in level? No, we're not in level. Yeah, ELP is still broken. I don't know how to fix it. I'm not going to bother. So there were where was it? A lot of stuff about merge. Right, so this top level was a constant. And there was this max level, and I think that this exists in the state of this process so that it knows how to find the next level to send something to. But it is weird that this is the max over this as the possibility that this level is greater. I would, I think it would just be max level, right? Anyway. Okay. So we translated that logic. And then obviously if there's no merge budget left, we don't continue propagating. So if we compute that there are 0 steps to be done, like we don't have any works and units left, or this is never going to be 0, right? But maybe this could be 0 because we've used up so much work in the lower levels that we don't have enough to continue going here. Then maybe we just return and there's nothing to be done. So no propagating merge commands, no promoting files, etc. Okay, so yeah, I think we can. Let's see. Yeah, so there's one thing here. This to do, I think, is straightforward to be to do, and that's we have this work completed, and what we were doing when we actually do some work. There's a work including here, and that's passed along to the next level. So I think it's reasonable if this level doesn't have a merger, like there's nothing to be merged yet. There's like maybe one file. Okay, it might still be reasonable to send a command, oh, wrong command. I don't need to, that's going to conflict. Here, we do this. It might make sense to do this and say work completed as the steps. And then it passes along. Make sure it didn't import command. Okay, it did not, because we've already imported that. Now there's a question. You know, we talked about max level. Yeah, and that being passed in. So maybe what we need to do here is go yeah, let's take care of this. Okay, so right, then we'll do so what I'm doing here real quick is right, it's telling me I'm being silly there. Okay, so if the current level is less than the max level, so we can promote to the next, then let's send on the command merge. Otherwise, we're going to return empty. Okay, so we took care of that to do. That's a good thing. I think we probably still need to address these things rather than giving an estimate. One of the aspects of this is that you can do one merge step that actually removes 2 keys, and that counts as 2 toward the budget. Because, one is either like newer and it's a tombstone and it removes, or it's like, newer and it supersedes. So that's one aspect that we're not handling here. Okay. Let's go up a level. Ha 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 ha. Level. Okay, so we've got our HanoiDB struct. And this contains all of our levels. It contains the nursery, and it contains a direction to where the path is. So this is where we will put our public API. So let's sketch this out. Let's think about what that public API would look like. So if you have an open HanoiDB, you would have a get of a key, and that's going to be a U8 slice, and that will return an option of a U8 slice, right? Or a vec, I guess. Maybe we'll say it's an option at U8. And then there would be an insert, and this is a key. This needs to be owned. There's a question here about whether this is result of option. Maybe we need to think about that. And this should be like result of nothing. Obviously this is, mute self. And when we're done with this, I'll just copy these signatures. But I wanted to think about this at first. So this could be result of option. It's a little bit clunky, but when you're dealing with the file system, multiple things could fail here, right? So you can't have the same kind of guarantees that you could have with an in-memory hash table, right, or mapping, that you would on an on-disk one. So I think result of option of U8 is fairly reasonable. And let's have a delete, or I would say remove, but there's a thing implied, with the existing maps in, so it's like B-tree map, right? If you do remove, it's going to return what was previously in that spot. But what we want to do is like that. We don't actually care in most cases on that. We're not trying to take the value out of RAM because it's on disk probably, right? What we're trying to do is say this thing is deleted, and then any previous instances of it in the on disk structure are considered invalid. So let's not call it remove. Let's call it delete. Welcome to the string, Zoya. So we'll say mute self, and then key. I think it needs to be evacuate because we are. It either needs to be evacuate, or we need to clone it immediately when we get it, which is not great. So this should be a result, right? Yeah, that feels like the direction to go. These are the basic things that you would want in a mapping, in a hash table, in a key value store. So let's talk about what we need to do here. So we need to check the nursery first, and the get is probably the most complicated. The insert and delete are actually just do that in the nursery because you're always inserting into the nursery, and then when it fills up, it promotes. So for the key, and then if it's not found, and here's the internals of this are going to be interesting because this, an option is not exactly what it returns. It's going to return something that's, because option doesn't tell enough. Like it's almost like a ternary type of value, where you either have the value, or it's a tombstone, or it's not even there. Like it doesn't exist in this level. And then check the. Okay, so if that fails, so if it's not in that level and it's not a tombstone, this makes me think we would need to potentially export that value thing that we have in this enum, right? So it should probably return these, and if it's deleted, we will short circuit with none, right? But if it's not even there, then we'll return. We'll go to the deeper levels. So okay, so we check the nursery first, and then they check the levels in order. Now insert, like I mentioned, is easy. It's add the key KV pair to the nursery, and this is the same, right? This is delete the KV in the nursery. And we may have called it remove in the nursery. We may want to, yeah, we did. Now also note that these return commands. So get, obviously works on immutable stuff. So we don't return any actions to be taken. But if you add or remove something, it could trigger the need to merge. So in each of these, we will need to handle any merge commands, right? So these two things are going to look pretty similar. And we may do something similar to what the nursery did, where it goes like right internal. And we'll see what happens. Okay. Before the stream started, a brief aside. I started writing, we had this to-do.md file. There's some aspects that we were talking about last week in the level, where there's some like safety mechanisms around moving files around, basically renaming them, where if the program crashes in the middle of that operation, which is not atomic, it's on the file system, we might need to recover from that scenario. So there's some recovery that we'll need to do at some later point. Maybe we can do that next week if we get far enough into the public API. But there are a couple. There's this one which was obvious based on the code. There's this other one that I thought about that could be possible. I think it's a hard situation to get into, but if you have an A file and a C file, but not B, what you need to do is move C to B. And I don't recall why this might. Oh, this could happen if you, in this merge dance, like this one, if you rename the merged file to M, maybe it wouldn't happen because you would delete A and then B. Yeah, so we need to think about the possible failure. Maybe this is not a donut hole state, but this is like a so this is not a donut hole state, but incomplete non-promotion state. So like A was deleted, but B wasn't. Right, so here we've renamed X to M. We delete A, but we crash but after we delete A, and so B never gets deleted. We need to recover that scenario, and then continue from here, basically, right? And then handle C. So there's optionally C. So B and M, but not A. Is a situation we need to deal with. Anyway, there are various recovery states we need to handle, but we're not going to do that today. I just want to point out that I did write that down, and yeah. Okay, so let's start implementing these. I want to do insert and delete first because there's no point unless you can read something or unless you can put data in there. Now we have example files that we wrote in the Erlang code that we would want to potentially be able to read as well. But there's our ultimate goal is to be able to run this completely from Rust code. Okay, so so we've got the opens. These are all internal stuff. So we're going to put some distance there. And I want to start putting some dot comments on here. Default min minimum level as 10 and maximum level as 25. We get some, there we go. Okay, and this one opens a directory. I think there was some RESTdoc thing you could do, like C or something like that. I forget how you do that. Or it was like equivalent to, we'll do that. Levels. Okay, we're literally typing what's in the code, but okay. Opens a directory as a HanoiDB instance with the given min and max levels. Okay. Let's save that. All right, so those are internal. So let's make our insert, and I'm going to copy the stuff that I wrote up here because that'll make it easy. Okay. Inserts key value pair into the database, HanoiDB database. Okay. So what did we say we needed to do up here? Let's copy that down. Okay, this is fairly straightforward. We'll go self.nursery, add, right? And key and value. Oh, that was easy. Now this returns a result of vec of command. So let's say commands. We could potentially go ahead and put this into a loop, but we'll do that. Okay. And then self handle commands. So that wasn't hard. You know, it's nice when you have built up this stuff and then the actual implementation just falls straight out. The exterior interface just falls straight out of you know, something nice you did in the implementation. Okay, so we can do the same with remove, right? Or delete. So let's go ahead and do that. Deletes a key from the I'm going to get tired of writing HanoiDB, so I think I'm going to say database. Okay. So here we go again. Self nursery remove. Now I may want to rename that. Chris, prime opportunity to introduce another acronym in the industry, HDB. Please no. We got BDB and MDB and yeah, no. Let's not. That is funny though. Okay. So now we're going to do the hard one. Let's do get. Okay, and I think I'll remove. Let's do a little bit of cleanup here. We don't need these comments because the lines are very simple. Now I was going to potentially inline the commands into this, but I think keeping them as separate steps adds a little bit of clarity for my sake. Okay, so let's see, looks up a key in the database. and returns its value if it is present. Okay. So it's not returning the whole pair, it's just returning the value. Okay, so now we need to look at these two steps. We may not have the stuff in the nursery yet, so we may need to I'm just gonna say okay, none, to make, or maybe we'll do a to do macro. To do is probably better. Okay, so we need to look at, does the nursery have this function yet? And I think it does not. It only accepts writes. Okay, so we need to first we're going to make this pub crate, and I think in the end I'll remove those pub crates because, you know, this top level API is the only API you get. And we have pub crate all over this place, but we're not exporting. You know, we're not exporting any of that. So, and again, we will change this from a main to a lib at some point. Well, let's document this. And that was really dumb, but that's of files. Okay. So we've got all this in our okay, so yeah. So we're implementing get. And we need to go to have something on the nursery. So the nursery, why I made this pub crate is we need to, like I mentioned, we need to know, should I continue looking or was this thing deleted? Now maybe there's a possibility of, yeah, we kind of have two things for this, unfortunately. Remember over in the format, we have the entry. So maybe what we'll do is name these specifically so that the call, and I really should break this file out into multiple files. You know, like get entry, because this has key val deleted or poslen, and we would not return poslen. But for nursery, it's a simpler value because we don't have, you know, it's not a B tree. I mean, it's got an in-memory B tree, but like we're not exposing the we're not exposing the innards of that. So here maybe what we call this, and I want to rename this to delete. And that means we're going to rename it in both of those files. So it's a bit more explicit in that what it's doing is inserting a tombstone. Okay. So let's say get value is the name of this. So get value. And this does not need to be mutable. And the key can be a slice of U8. And this is going to return. Now this does not require any file operations, so we don't need result. It should return an option of a value. So we'll do self data get. Right, so this directly returns what we want. That seems a little dumb, but bear with me. Again, when your design is good, the top level things fall out. So I'm hoping that this will be the case. Okay, so first we need to do we're going to match on self nursery get value of key. Okay, and let's fill out those arms. So it's going to return sum of value if it's deleted. Then what we want to do is return okay none, right? Because we know that none of the other levels, I mean, if they have values, they're all invalid because we wrote this deletion. We deleted this key after we wrote those values to the other levels, so we don't need to continue. Now I could not flatten this, but I'm going to flatten it. What I mean by flatten is value, and that's return value. Okay, and then if it's not there, then we'll continue. So maybe we could do something like you know, if let this is okay. This is okay. So now what we need to do is we need to do something like So if we've gone through all the levels and nothing is returned, we should return okay none. But now we need to get the levels and why did I have mute self? It doesn't need to be mute self. We're doing immutable here. I'm thinking that this, no, that's fine. Okay, I got something wrong here. We need value as ref. That's not right. Okay, I'm gonna have a problem here. Is it as slice? Oh, okay. So I'm sorry. The problem was this. I didn't say okay sum. I was like, what's going on? It's already borrowed. Okay. So we're gonna loop through all the levels. And then we're gonna do match level dot, we're gonna say get entry. And we're gonna pass key. Now we need to implement this, right? So we will have something similar to this. So let's just go ahead and pretend that this exists. So we'll say sum, and this is going to be entry. If it's deleted, and we don't actually care what the contents of that is, we assume that it got the right thing, then we will return okay none. Right? If we get a key value, and again here we're not caring about the timestamp yet. We just needed to support that. Okay, so we only care about the value there. Then we're going to return, okay, sum of value. And value as ref. Okay, that's a case. This is a thing. We might not need that because I think that what we'll do is say that get entry returns an option of the reference to an entry. I don't know if you all remember from some episodes ago, but we had to deal with owned versus not owned when reading the file. And it was kind of a mess. And like, I didn't want to have two data structures that represented the same data, where one like had references to slices and one had owned slices, or owned vex. And so we just went to owned. There's some potential implications of that. There's one more case we need to handle here, which is poslen. It should never return this, but we need to handle it and go unreachable. Returned a poslen entry. Like that should never happen. So if it's none, then we just continue. And now we can go implement this. Okay, so REST analyzer is like, I don't know what the heck you're talking about. Okay, let's go look at the level. We have a lot going on here. Okay, so we have new. Let's see what else we have in here. Okay, so those are only public functions. So this is where it'll get interesting. Let's put it here. Again, I'm going to remove those pub crates later. Okay, so this is going to take self, and this is going to take a key, just like we did, slice a U8. And this is going to return, and this is the part that I didn't do right. I think this needs to be question mark here, because we're dealing with file operations potentially. This is going to return result of option of entry. And then we could do this. Let's find out whether we need to do that. Okay, so there is something in the format tree. I think we already implemented the bits in tree. Yeah, we implemented get. Now this returns option of vec of U8, so maybe we don't need the result. Yeah, so okay, so there's some bit here where we're actually swallowing the result. Now that's getting yeah, this is not the right, I mean, this has some of the stuff we want, but this is not the right API. Because here we're saying, just get me a value out of it. But what we want is the actual entry. So we're going to have to redo this. But it's going to have a similar structure. And I think what we'll do is we'll not do those OKs. We'll have result of option of entry. Okay, so well, this sucks. Okay, let's pretend like that exists. And what we're going to do is similar to this promote file, right? We're going to do this, but in reverse order, because the newer stuff is in the later files in the alphabet, so C or B, right? So we'll do something like self.c is sum. Then can you do if let? Okay. Right, and this is going to kind of be like continue like we did, up here, we're going self levels. Okay, so we'll say this is going to be some repetitive code, but we want this to be like, okay, some entry. Actually, we want... So if get entry returns a result of option of entry, we basically want to return that. But if it's none inside, then we want to continue. Okay, so let's say let entry, and this is going to be option of entry. We'll start with none. This is kind of dumb, but it's going to help me think about so we'll say entry is this, and we'll put a question mark on it. So if like that fails, then we'll immediately return the failure. Okay, so this is, we've kind of determined that. Maybe I could do this in a loop. Let's see what that will look like in a loop. Okay. Okay, so we're going to say for tree in, and we're going to borrow self.c, self.b, self.a. And here we're going to return okay, none. So if we didn't find it, except we don't need to do return there, it's just the value. Okay, so okay, none. So here we go if let sum, we'll call this file just to be clear, file. Okay, so if there is a tree to query, then we want to, we need to see if it will get, see if we can get the entry, right? So this is what we were doing before. Okay, we'll so do this. if it does exist, we want to return entry. This is a little bit wonky. Maybe we could go. Because I'm trying to unpack this. Maybe do another if let sum. Yeah, I don't see a better way to do this. It feels like I should be doing file.map. So let's see if that file.map has any legs. Okay, so this is a tree. So we do tree.getEntry. Except we don't want question mark in there. We pass the key. So then it's like, so now we have an option of a result of an option. Yeah, this doesn't feel right. This doesn't look good. But I think it's okay. It doesn't feel right in some way. This is a lot less verbose and confusing, I think, though, than the if C is some. Oh, hi, RX. Sorry, missed your question. What is HanoiDB? HanoiDB is a KV storage engine that was originally written for the React NoSQL key value store. And we are re-implementing it in Rust. It was originally in Erlang. In fact, I've got the Erlang code open here. So we may be switching back and forth to learn about things. But we're focusing mostly on the Rust side now, and yeah, we're trying to build the public API now that we have a lot of the guts of it built. Okay, so we need to implement this get entry, right? I think this is good enough. So try each of the files. If that tree exists, so we're trying them in reverse order. If the B tree for that file handle exists, then we try to get an entry out of it. If it does, if we do get an entry, then we return that. If we don't, we go to the next one. And if we don't find it in any of them, we return none. So like it doesn't exist in this level. Okay. Which is different than it being deleted, right? Because we want to, if we get a tombstone, we definitely want to return that. Okay, what did I change over here? Right, okay. So we need to go here and implement get entry. And the key is going to be U8, slice of U8. And this is going to return result of option of entry. And, you know, I think we want to see if we can return borrowed, but since this is reading from a file, like all of these return owned. So here, that's an owned entry. Maybe we just like avoid trying to pretend that it's borrowed. And here, you know, we'll use as ref or as slice, I guess, if it's a vec as slice. Yeah, and this is return owned. And that's just a consequence of the fact that we're not using mem mapping yet. We're just doing file operations. Okay. So if this is the API, let's implement it. Now again, we have a bloom filter here, so we could, you know, when we add the bloom filter to the files rather than just leaving it empty, we can handle that. But we're gonna have something very similar to this, right? So let's copy and modify because I don't want to be re-implementing this logic, I do recall it being kind of complicated to understand. Okay, so here we'd still want to, now we're going to remove the OKs because we want to propagate the results. There's another place where it's okay. Yeah, because we're not trying to return option, we're trying to return result of option. Okay, so let's read through this. So we get the root block and we start looping. If the level is greater than 0, so in other words, it's an inner node of the tree, then yeah, so if we get an entry here, then we try to jump to that entry. And here's, if we don't find, if we scan the entire key space and this is proceeding, well, I actually wouldn't scan, but if it proceeds, anything that's in the database, we return okay, none. Okay, so let's see here. So now now what we'll do, I think we have, let's go to the entry definition. I think we have a method on entry which is key. We do. Okay. So what we want to do here, rather than find map, we want to do find and this can be much simpler, entry.key. Sorry, I've been doing too much TypeScript, equals key. And right, so this is, we're no longer in, we're on a leaf block. So it either, this block has it or it doesn't. And I think we want to do this. Yeah. One of the interesting aspects of this, I said it should be result of option. This is for consistency. But by the nature of iterators, this, this entry iterator, it doesn't return result of entry. It returns entry. So it is swallowing, right? And we have a to-do, right, of don't swallow the result. So like our self item should be result of entry, probably. However, this does ensure that if we get an error, we stop iterating. Not ideal. We could improve that at a later date. So in a sense, our our get entry method is lying a little bit. Because it's using the entry iterators and then those swallow errors. So like the only places that we're going to potentially return an error is if we can't find the root block, so that would mean the file is corrupted, or at least the trailer part of the file is corrupted, or we can't scan, or we can't seek to this particular position in the file to find the next block to look into. So that sucks. Interestingly, we could probably here, because we use this entry.key, we maybe don't need to match. This is a little bit of a paranoia that we didn't insert a key value into an inner node. Okay. So okay, so now we're actually returning an entry, which means we can go up this level and it's like, yep, I'm fine. And let's go up here, and this. I think as slice is. This is partly where maybe our API is not great. Maybe what we need to do here is do clone. I don't like this, but I think we need to do it. And so here we do, okay, sum, and here we clone it. Really, like, I could have gone the other way. I think making this, the problem with returning a borrowed value here is this is owned. When you leave this function, that value's dropped, so it doesn't live long enough. So we have to pass it to the outer context. We have to give ownership over to the caller, which means that values from the nursery will be cloned. Just a problem of, again, if we were using memory mapping, then maybe it would look like a borrow all the way through. Would make some other things more difficult. Like, as we found when we went to make these different iterators, we have the iterator, the owned tree entry iterator, and the tree entry iterator. And this one borrows and this one doesn't. And that feels like a little wonky. But, like, man, the lifetimes were killing us. Okay, so yeah, we can close that. So let's start thinking about some tests. First of all, let's compile. Make sure that, cargo build. Starts thinking mix compile. I don't know why. Okay, so it's going to be like, yeah, these are never used because we're never calling them from main. So let's make this. I think we need to toss this file, honestly. Yeah, let's first make a commit. Okay, so we're going to do implement the basic API operations for key value pairs. We are not yet implementing scans or folds or anything like that. I think that's something that we will do much later. It is possible, not hard, like not much more difficult than what we've already done. But you have to be concerned about, okay, let me take a step back. In the original Erlang code, you have to be concerned about concurrency. So it hard links those files as they're being folded over. And that means that you've got, you have the possibility of completing a merge on a file while you're still folding over the existing database. So it's almost like a snapshot. But we have built this with single threaded. We'll need to change that eventually. because, well, real applications don't really run single-threaded. Okay, so we're going to do, let me say, this is session 12. And it helps if I add source. And then we're going to do some cleanup. So we're going to maybe move this to an example. I think if I move it to an example, it's going to break because it's going to be using stuff that's not. Okay. Yeah, we're going to do. Let's just make a new file. And this is going to upset Rust Analyzer for a bit. Okay. And then we're going to do pub use db HanoiDB and pub use error star. Yeah, I think we're not going to use this because we're going to start making tests. Do like some integration tests. This was useful early on when we were trying to just go, can we read the files? But we're going to need to do something a bit more deep than that. Okay, so I'm going to actually get rm source main.rs. Yeah, force it, please. Okay. So now let's see what the warnings are. So I got rid of the, dead code. It says path is never read. It might be useful. I'm not going to do that on handle commands. The directory that contains this database's files. And let's say path self, and this is going to be path self.path as ref. That's not right. Oh, no, that's what I want. Okay. So then we get rid of that dead code warning. Okay, let's see. This says merge done is never read. And I think we're not, when we're doing this, yeah, we're not using it here. I think that field for now is probably not useful because we're not writing to it, we're not reading from it. Okay. Compression is never read. Yeah, because we're not using compression yet. The defaults in the in the original code are to provide these 4 or these 3 compression methods. The default is no compression. I think this one is worth putting a comment on, and we'll say allow dead code on that field. And there's a to-do here, which is we have to implement compression on reads and writes. Okay. Let's see. Entries and get are never used. So we are using that internally, right? Yeah. Hi, Isaac. Good to see you. I'm doing great, thanks. We're in the midst of cleaning up the mess that I made. Okay, so let's make this just internal. The thing is, let's boo. Can I jump to that? Okay. Are we not using that in? No, we use block entries. This might be use. We're gonna leave this around and put a do note on it. And I'm gonna say to do. I'll leave it pub. Doesn't matter. Use this for full database folds. Scans. Right. We aren't using it anywhere else, but we shouldn't delete it just yet, because if we delete this, then this type becomes unnecessary and we have to delete it, and so forth. Okay. Cleaning up warnings. Okay, so this, right? So I think that this is fine to delete. We've got basically the same implementation up here, but we're returning an entry, not the value inside that entry. I think this is overall more useful. We're not going to be necessarily trying to find. This is like to test if we have like implemented the file structure correctly. Now I'm going to put this here because we do need to eventually deal with that. But yeah, I think we can reasonably delete that function. Definitely not used. We don't intend to use it because now we've got the high level API. Okay, now let's see here. It's lots of problems. What's going on here? If let, since only the sum variant. Okay, Clippy, can you fix it for me? Manual flatten. Okay, so is it... And then we can get rid of this if let. That feels a little better. Okay, so thank you, Clippy. Very helpful. Now this one, yes, +1 for Clippy. This, I could put this as box merger. The thing is though, this consumes self. So it feels kind of a pain to box that just to make this feel better. Now, the other option could be that we use a smart pointer to hold a merger, like an RC or something, and then also looks like a filter, but plus first. I'm sorry, Isaac. Are you talking about this? Possible, yeah. Um, okay, we were over in merger. Um, Again, the issue here is ownership. Like, because we need to own this in order to be able to close the file that's in X, um, without, like, because we need to consume this that file handle, that writer. Um, like, that is a safety thing, right? Because if we close the writer, then like it needs to close its file, and like it needs to be no longer valid if we've closed it, which is a problem if this is, doesn't have some wrapper around it, or if we don't have some kind of wrapper around the merger. I think at this point it's I'm going to, what is this warning? It's a Clippy. It's not. It's a large enum variant. Okay, so I think we're going to leave that. And I'll put a note on it. Um, let's put it here. Actually, that's probably on the outer one. Um, and again, it has to do with, we want to do this work incrementally, and if we run out of work to do, or like if there's no more work to be done in the merger, then we excuse me, then we want to get rid of this. Like, it should come out with, there's nothing left. That merger is closed, the writer is closed. So I guess my point here is I'm trying to convince myself that it's okay to put this allow on here. Um, Consume the merger when its work is complete. But if it is incomplete, it should continue to persist. So we have kind of a chicken and egg problem. Egg problem with the lifetime of the merger in the outer context. I don't know if that makes sense. This, okay, we'll just leave it at this. Therefore, we suppress the large enum variant warning. Because it's not like we could, I mean, we could say that this passes in, like, again, some kind of smart pointer where we could take, like, this is maybe like maybe it passes in a box, in which case we should just return box here. But it could take it out of, oh, maybe we could do that. Hold on, folks. um, Okay, but bear with me. So this merger is owned by the level. It's an option. So what we could potentially do is where are we using that? So like merge. Rather than doing self merger take, what if we did passed a mutable reference to that option into this, and we called this as a like a type method rather than, or type function rather than a method. So this would be, rather than mute self, this would be option self, right? And this would be, we'll call it merger. And here, I think the idea would be that we could, replace this with none. Uh, to be threaded here. Let's finish this thought, and then we can maybe consider that for a future time. So let's say the other option is to pass a smart pointer of some sort. The option merger to the incremental merge method so that the contents can be consumed when the merge finishes. So this is something that we can possibly handle next time. I actually don't want to change this right now because I'll have to go change a bunch of things. Obviously, I was starting to get upset or worried about the mute option, self here, and then going, oh, now I have to handle option inside here. Even though we'll never call incremental merge unless the merger exists. Sean Parent. I'm sorry, I don't know who that is. No raw loops philosophy. Yeah, like, my background is from, in a lot of ways, from functional programming. So my tendency is to go for, chains of combinators on iterators. But there are a lot of times, I think I've learned over the last couple of years writing Rust at work, a lot of times are like, a for loop is just easier to understand. On the other hand, sometimes you can write a for loop that you're like, why the heck is this a for loop? When, okay, he's from the C++ community. Interesting. Oh, so he would be more like, you always want to be looping over a collection or something rather than like, loop over numbers. That makes sense. I can get on board with that. You want to have a good idea of why you're doing, a particular thing. Anyway, yeah, there are a lot of cases where some things will be hard to express as chains of iterator methods. Like, especially if you have some side effect you want to create, in which case you're like, oh, well, now I'm doing a fold or reduce or whatever it's called in Rust. I don't use it, so I don't know. Instead of doing a loop where you have some memory location that is a side effect, like having a let mute something outside the loop and then setting the value of that from inside the loop at some point. Anyway, or returning early, like, is another case where loops are a little bit easier than chained methods where you'd have to use something like find map or something like that. Okay, so we've gotten rid of those warnings, with the caveat that this thing is big because that merger is big compared to this, and we need to address that later. But that's complicated, so I'm going to leave that off. And now the other cleanup I want to do is find all the pub crates and remove them, just make them pub. Right, because we're not exporting this from the lib part, so we don't need pub crate. And thank you, Zed, for having this multi-file editing thing. It is so good. Even though I'm gonna like manually select things and delete them. Okay, and then we'll have about half an hour left. Maybe we can write some tests and see how broken my code is. Won't that be fun? Yeah. Okay. Pub crate. Again, doesn't need to be public to the crate. It can be pub because we're not exporting it. And I just added that today. I should not have. Let's just do pub. Yes. Yes. Okay, so we have no more pub crates. All right, good stuff. Okay, session 12. Clean up internals and address warnings. When it works out by chain, it can be so nice, but when it doesn't, both often feel bad. Yeah, that's true. Again, like I said, I'm a big fan of functional programming patterns there. What I would do differently in Elixir or Erlang is that if I can't, also in Elixir you have the pipe operator, which is super nice for that stuff. But when I can't express it like that, I might actually make a self-recursive function where that side effecty thing, like I managed with, like I mentioned about for loops, I would put as a second or third parameter or argument on the function, and start it with a default value. And then when I reach whatever the termination condition is, I return that thing. But I don't do that in Rust. It's very, very different in that respect. Okay, so we're going to add the to-do. And I know we have to-dos littered around the code as well. But let's add that as a commit. Update to-dos about recovery. Okay. And let's go ahead and push. Okay, so now let's think about some tests that we can write. Let's make a new folder. I think it's supposed to be tests, and that'll run your integration tests. Okay, so let's do something like let's call it, this is going to be done. Let's call it public API. Okay, and this is going to be config test. Well, I don't think that's strictly necessary. So let's do a simple one like so we're just going to start with example tests. I think that's good. We're going to need some some infrastructure here. Like we're going to need to be able to create like temporary directories. Let's see. Directories that we throw away at the end. I wonder if there's a good. I bet there's a good crate for that. Let's have a look. Crates.io. Okay. Temporary variables. Uh, simple temporary file with cleanup. Chris, do you happen to know any of this? I just want something that like I can open and have it be all cleaned up. I don't want to write that right now. In my work at Fable, we have our background processor uses a lot of temporary directories just so it makes sure it cleans it up at the end for stuff like take all these files and encode them into a video, all these images and turn them into a video. That's a pretty common thing. And so we have these helpers that are like with temp directory and they're great. But yeah. Temp tester is really hard to know. I think maybe we do like, let's look at lib.rs or blessed.rs. Okay, tempter, yeah, they don't. See, this is probably the one. Temp file. Get temporary files. Let's look at the docs. Tempter, creating temporary directories. Okay, this is the sort of thing that we want. Okay, so we're going to do, before we do anything with this, let's do cargo add, as there's a dev flag. Yeah, dev tempter. That was the name of it. Temp file. Yeah. Okay. So let's use temp file tempter. That's what we want. Okay. So let's do a read. Let's say read empty database. That'll be a test. Okay, so we're gonna do let dir is tempter, and we'll unwrap that because we should panic. And then we'll do dir.close. Okay, so let's import. Oh, yeah, this is an integration test, so I need to, let's just import star. Okay, and we will do db open dir. So it should open that. And then, and again, so if you're not familiar, like in tests, it's best to panic because you want it to fail right away and understand why it failed. So that's why I'm using unwrap here. You could use expect if you wanted. Yeah, so let's do db get and no, not delete, get. And we're going to do, we'll just make a string key as bytes. Okay, so we've got a static string. And then, so that's going to be a result of options. So unwrap, and then we'll do assert value.isNone. So, you know, really dumb test, but it exercises here, we'll borrow that. It exercises a lot of things. So it's going to exercise opening. Okay, that doesn't need to be new. It's going to exercise opening the database. It's going to exercise trying to read something from it. And then, you know, showing that we get the right thing. So let's see if we can cargo test. Okay, so dumb test, but it worked. Okay. Let's do a insert KB pair. Let's do another simple test. So we're going to do a lot of the same things here. So let's do db.insert. And then we will do, let's say, key. So this is a string into say as bytes collect. And this is, we'll do the same thing. Okay, so we're going to make sure that it writes. Oh, thanks, Isaac. Very nice of you. Okay, so we're just checking here that we can, you know, let's actually pull these out and say let key is this. And that's probably not the most elegant way to do that. But our database is using bytes. It doesn't care about encodings. You have to deal with that yourself. And yeah, so we're going to clone those here. Again, we're not concerned with efficiency in tests yet. We're only concerned with correctness. So dir close, we need to make sure that we have that on every test. Okay, so oh, let's just do, it's not an iterator, so it wasn't collect anyway. Or is there an into owned? Can we clone? Yeah, let's clone. Okay, so we do need to clone it twice, unfortunately. The other possibility is that we could do string from and then into bytes. Yeah. I like that better. Kind of dumb, but okay, and the reason we need to clone it is that we need to clone it for the insert there is that we want to make sure that we can compare. So then we're going to do assert equal. and this needs to be mute. Yep. So we're going to do get, we'll borrow key, and this is going to be unwrap, right? And then we'll do, it's going to equal sum value. Okay, so that's an insert read round trip. And I don't have, do I have cargo watch installed? I do. Actually, I need to cargo watch. We'll just get it to run the tests. Cargo command. Okay, so cargo watch x test. Okay. And I actually want to see about putting this over here. Yeah, there we go. Okay, so now we're going to do insert and delete, right? And we're going to do a lot of this. In fact, we'll kind of repeat that bit, and then we'll go db.delete key. And then we're going to do this. And we need to clone it again here, right? And this should return none. Okay, so, you know, our tombstone thing works. Now, one thing that we should do that comes to mind, I don't know that we have a method on here for close. And I think we're just relying on drop to work. Yeah. We don't have something that explicitly closes. So, maybe yeah, so let's do let's call this one nursery recovery. Because what I want to do is let's do this and make sure to do the closing at the end. So this is going to be, we're going to open a scope here where we insert a value like we did here. Oops. And then we drop the database. So we drop this handle, which means all the files get closed, including the nursery. So let's put this up here. So I'm going to put a little comment in here, open the database, insert a value, and then drop. Maybe just to be clear, I'll do drop. Now, it will fall out of scope, so like it's gone after this. But by dropping it explicitly here, I'm kind of saying we're closing. Maybe we should have an explicit close for safety's sake. I don't know. Okay, so now we're going to open it again. And then we will do this, right? The main thing is we want to open it again. Hey, and that worked. Yay, cargo watch. Okay, so this is saying we've written a value, we close the database, we open it back up, essentially reopening those files, and then we read back the file that was written previously, and the log was recovered. Yeah. Okay, and I'm not gonna say this is nursery recover. Let's say open. Let's call it open existing dir. Um, insert and delete. Okay. Yeah, so this is pretty good so far. We got about 15 minutes left. Might consider doing. I actually don't think we need this config test in there. It'll still run the tests regardless. I think we can do. These are happy path tests. We're going to get more sophisticated to write some things that might break it. Obviously, we didn't exceed the number of keys here. So we probably need to write something that we probably need to write something that inserts a ton of keys, such that it'll force the nursery to be written out to the first level and see that it still works. So let's go ahead and do that. Let's say call it lots of entries. And this will be a really dumb loop. That's Okay, and then we're going to open. And you see there's some patterns here. We could potentially go, write a macro that injects this directory into the test function as an argument or something. Or maybe there's a way to tell cargo test that, hey, this is a suite, or like common test in Erlang, and then give it different parameters. Okay, so let's this will be similar to what we did back when we were working on BerkeleyDB, where it like injected a bunch of things into the data file in a loop. But we know that the base level is 1024, so let's see, let's write 2k keys. Okay, so we're going to say like key is format key I into bytes. Let value is format value I. And now these aren't very big, right? But what we want to do is make sure that this is like an end-to-end test, right? So we're going to go db insert, not into, insert key and value, unwrap. And the main thing we're going for here is that we don't crash. Right, because this insert may trigger a merge, in which case all of that other stuff will be invoked. And so let's see. This one is going to be slow, right? and it passed. So what I might want to do here is maybe we debug. I want to do standard. I want to like basically ls that directory, but with code. Reader. Yeah. Does that not return a... Oh, unwrap. Unwrap. And collect. Let's go vec. Because I want to see what files are existing in that database. Except it didn't print it. Reader. It did not print it at all, did it? Well, let's do something like this. Okay. Oh, this needs to be just HanoiDB. We don't need to import the custom result type. That was a problem. Okay, and then we'll see what happens here. Hopefully it'll actually print to the console. Okay, we will print to standard out rather than standard error. And then we'll wrap up for the day. Okay, I did not see it print anything. So this is wrong. This is just not doing what I want. Cargo. Tests. Yeah. Maybe passing tests are quiet. Yeah, that's a possibility. Test help. Can I... Let's try... See if using verbose output will... Verbosity. Verbose output will actually print the output. I have done this before, but I just don't remember how I did it. Okay, yeah, that's not helping. Um, the other thing I could do here is just make this fail. We'll panic. Show me the money. Okay. And then it'll run. Okay, so it still didn't print the output. Maybe we do. I don't remember if the edition I'm on supports, or the version I'm on supports this, but we can try that. Hopefully it doesn't print files question mark. Oh, it actually, okay, so it printed them out. So we have a merge file and a nursery log. That's interesting. What's interesting to me is we don't have an A and B file. Okay, so I think this is a good place to stop. I'm gonna get rid of this stuff, and that'll be passing for now. And then we will, for the next time, we'll think of some other tests to write. And I specifically, I think it will be worth us going into the lower level stuff. So like, let's create a database with some stuff filled in, and then, excuse me, and then like open an individual file in that directory, for example, so we can test the format. Or easy one is the writer, and I think that we already kind of tested that, but we could potentially test this thing specifically, and then we can start enhancing the implementation. So we can start doing something like, we can figure out what kind of bloom filter like thing we want to use, and use that. We could add compression. So I think this is a great first start, and I wish it hadn't taken me this many sessions to get here, but not gonna lie, it feels pretty good, and I'm really grateful for all of you being along on this journey, and we'll continue this because I think I'm having fun. I hope you are too. Anyway, we will see you next time, next week probably. I will make sure to update all my socials and the YouTube page with the next session. So take care, and we'll see you next weekend. Thank you for coming.